This lesson is about physical properties, and the learning target is to be able to explain how physical properties identify substances. So physical properties are characteristics of substances that can be observed or measured without changing the identity of the substance. So if I had a cylinder, maybe I didn't know what this cylinder was, and I was trying to figure out what the identity of it was. Maybe I was trying to find out if it was gold or copper or iron or anything else. The physical properties of this cylinder are what's going to let me know the identity of this cylinder, and that's what we're going to be looking at today: is what physical properties can help us figure out the identity of substances. So the first things that we need to know about physical properties is that there's two different types. There's physical properties that are size dependent, and there's physical properties that are size independent. And what size dependent really means is that does this property change if there is more of the substance? So for example, if I take this cylinder and make it bigger, does this physical property change? That would be a size dependent property because it depends on the size of the object. If it's a size independent property, that would mean that no matter how small or how large I made this object, this substance, the physical property does not change. And those are going to give us really good clues as to what this, this substance is. And we're going to look at these in more depth in the next slides. So these size dependent properties are going to depend on how much of this object we have. So things like mass and volume just make sense because if I have more of this object, I have more mass. If I have more of this object, I have more volume. If I change the size of this object or this substance, I have less. If I make it less, I have less mass and less volume. And so these properties of mass and volume are going to be great for identifying substances because they change depending on how big the thing is. But they are going to be good for describing what these substances are and communicating that information to somebody else and communicating information about the object that we're trying to identify. So our size independent properties, the ones that don't depend on size, are going to be the ones that are important for identifying our physical, our substances. So the size independent properties are the ones that we're going to really use to identify substances, and the ones that are going to help us as we start talking about how do we separate mixtures, how do we tell if a chemical physical change has happened, all that sort of deal. And the first one that we're going to talk about is density, which is the amount of mass per unit of volume. And so if I have my unknown substance here, my little cylinder that I don't know what it is, I can use the density to help me to figure that out because no matter how big or how small this substance is, it is going to have the exact same density because its density, if we were going to calculate this out, is equal to the mass of that object divided by the volume, the space it takes up. And so even if it takes up more space, I'm also adding a certain amount of mass in that object. And so its density, this ratio of mass to volume, is going to stay the same. And that's going to help us to identify the object because each object is going to have a certain type of density. It's going to have a certain amount of density, whether it's gold or copper or iron or anything else. Another one that we can use is the melting slash boiling point. So each object, each substance, has a certain melting and boiling point. You guys know what water is. It melts at 0 degrees Celsius. It boils at 100 degrees Celsius. Um, and that would be different for any substance that we'd have. And so what we could do is we could try to melt down this cylinder and see what temperature is this thing going to melt at. And we'd be able to go and look and find a table of substances and figure out what their melting points were. You know, maybe copper melts at this temperature, and that's what our substance melts at. So now we know that it's probably copper, or it could be at iron's melting point, or it could be at gold's melting point. But the melting and boiling point is going to be specific for those types of substances and help us to identify that object. We could also look at the solubility. And so this is going to tell us whether or not, or what the solubility is whether or not this thing dissolves in another substance. And one that we would really look at is water. Well, does it dissolve in water? Because some substances will dissolve in water. If it was, maybe a big block of salt and then it started to dissolve in water, we would know, okay, well, it dissolves in water. That's going to tell us a little bit. It's soluble. It's soluble in water, we'd say for that. Or maybe it's something like iron where it's not soluble in water. Depends on what the substance is, but that could tell us a little bit more about what this object is. It could also be soluble in something other than water. Maybe it's soluble in oil, for example, but it's not soluble in water. Well, that's going to tell us a lot about the substance that we're dealing with and the compound that we're dealing with. So solubility is another property that we could have here. Magnetism is also another important one that we could help use to identify substances. We could find out, is it attracted to a magnetic object? And if it is, then we know what type of metal it is. We could look down what metals are magnetic and which are not. If it's not magnetic, that's going to tell us that it's going to rule out some metals that it could be and couldn't be. So magnetism is that attractive force that could also help us know if this thing, what the identity of this object is. We could also look and see, does it conduct electricity or heat? Because some metals will conduct electricity or heat better than other ones. Some substances will do the same. So we could look at that to tell what is this substance. So conductivity is another physical property that we can use to identify whether or not this thing um, or what this thing is. And so these are the size independent properties that we're really going to be looking at to use to identify our substances and to use as we get into separating mixtures. We have density, the amount of mass per unit of volume. We have melting boiling points, the temperature that materials change states. We have the solubility, whether or not it dissolves in another. We have magnetism, which is the attractive force for some metals. Not all metals are magnetic. And we could also have, does it conduct electricity or heat? What is its conductivity? And that could help us to identify this substance. So what are some real examples of using these physical properties to identify matter? Why do they matter? Well, we were trying to find the identity of an unknown substance, this cylinder down here. If we were trying to do that, um, we could do that by finding the density. You've probably heard before that fool's gold and real gold, one key way that you can identify them is through whether or not they shatter when you hit them with a hammer. Fool's gold, you've maybe heard, when you hit that with a hammer, it's going to shatter into a bunch of different pieces. But if you do that with real gold, it's going to flatten. And that's why you see people take gold medals and put them into their teeth and bite down on them to see if the teeth marks show up to show that it's real gold. That's why that happens, is because real gold is malleable. That's another physical property that we can use to identify substances. If you take a hammer and hit real gold, it's going to flatten, it will not shatter. But another way that we can identify them is through their density, and this is 4.8 grams per centimeter cubed. And it's the same thing with real gold. 19.3 grams per centimeter cubed. So if we were trying to find the identity of our unknown substance here, we might put it on a scale, find its mass, and we might have to submerge it underwater if it's not in a really easy way to calculate the volume of it. But we take the mass and we take the volume, we divide mass by volume, and we would end up getting our density. And if we saw that our density was close to 4.8, we would know, well, this is probably fool's gold. If we know that it's closer to 19.3, it might be real gold. It might be something where we can just say, yes, this is what it is. It might be something where we have to do some more tests on it to figure out. But density is a really key way that we can figure out what these properties or what these substances are. And so another way that we can do that is by using a fractioning column. And when we take crude oil is made up of a bunch of different compounds. And in order to use those, we need to separate them out into the various compounds so that we can use them for the best use that they have. And so when you take crude oil, goes in here, goes into a fractioning column, it gets heated up, and you can see that we have different boiling points for all of these different compounds. And because they have these different boiling points, they are going to go into separate areas of this fractioning column. We'll be able to take them out. You see that refinery gas is going to be the lightest one, go up way up to the top, and we'll be able to take that out and use it for bottled gas. For regular petrol, it's going to boil out at 70 degrees Celsius, and we'll use that for vehicles. We have jet fuel is going to have a different type of compound than bitumen would for roads and roofing. And so you can see that the boiling point really, really helps us separate out these mixtures in our crude oil. And separating out mixtures is where we're going to be going with this. How do we use the physical properties like melting point, density, things like solubility to separate out mixtures? And so I hope that this helps understand the physical properties of substances and how we can use those to identify the substances.